but section 2.2 is about subsets. So when we're dealing with realistic sets, the cardinality aka the number of elements, can be very large. So for example, the set A consisting of all NFL players would have almost 1,700 elements. Which is gigantic. But maybe we may only care about a smaller, more manageable set. Like the quarterbacks of each team. There's a lot less than of those. I don't have 1,700 quarterbacks. Not everyone is that position. Okay. So these groupings, though, still fit in with that bigger, larger set, but it is a smaller portion of them. That is exactly what a subset is. So ultimately, we say set A is a subset of set B, which is denoted by A first, B second. We use this C with a bar underneath it. So we say set A is a subset of set B if and only if all the elements of A are also elements of B. So it's kind of like an inequality sign that you learned about. A is less than or equal to B. Basically, everything that's in A, also in B. And anytime we want to say something is not, we pretty much put a slash through it. So we can use A is a subset with a slash through it, B, to say A is not a subset of B. So all of those elements in A are not in B. Okay. So let's try a few examples. We want to determine whether set A is a subset of set B. And so our first one we're going to work with, set A contains the elements dog and cat. Set B contains the elements cat, fish, dog, and turtle. Okay. So if I look, dog is in A, it's also in B. Cat is in A, it's also in B. All of the elements we have in A are in B. So since dog and cat are elements of set B, we have A is a subset of B. Okay. The reverse, however, is not true. If I try to say B is a subset of A, fish is not in this set. Turtle, not in this set. Okay. So on the reverse spectrum, we can say, however, B is not a subset of A, since the elements fish and turtle are not elements of set A. So not everything in B is in set A. So that reverse doesn't work along. Okay. Let's try a few more. We've got set A, which contains the elements Harry and Draco. And we've got set B, which contains the elements Harry, Ron, and Hermione. Okay. So we're okay with this first element. Harry is in set B, but our problem runs here with good old Draco. So ultimately, since Draco is not in set B, we have A is not a subset of B. So that is our problem. Not everything in A is in B. Right? So I got one more. A contains the elements 1, 2, and 3. And B contains the elements 3, 2, 1. So if I go ahead and match it up, 1 is in set B. 2 is in set B. 3 is also in set B. So here, all the elements in A are also in B. So indeed, A is a subset of B. Really, the reverse is true, because if I look at starting at B, all of the elements in B are also in set A. So in fact, B is also a subset of A, and these two sets are identical. So A is equal to B. This is kind of cheap. The subsets really work, but these sets are exactly equal. And so that's kind of boring. Where back here, I couldn't say both of these are true because I have some stuff that's in set B that's not in A. Set B is a lot bigger than set A. That's what we like a lot more. So this leads to another type of subset, which is called proper. So these two are exactly the same. This is not a proper subset because they're identical. So we say set A is a proper subset of set B. And it's denoted in a very similar manner. You still have A, you still have this C-looking thing, and set B. You just no longer have this bar underneath it. So that bar is basically indicating the sets can equal each other. Now they can't. So it's denoted in this way, if and only if all the elements of set A are elements of set B, and A is not exactly the same as B. Okay. So essentially, set B must contain at least one element that's not in A. Okay. It must be, or it must have a larger cardinality. Okay. So let's go through using the same examples of the stuff that was subsets. Let's determine if A is a proper subset of B. And we're going to work with the same first example. Set A is dog and cat. Set B is cat, fish, dog, and turtle. Okay. We already know from the last example, A is definitely a subset of B, and these two sets are not exactly the same. So basically that allows me to drop this bar. So yes, A is a proper subset of B. If they're not equal, I get to drop the bar. Okay. While in the second example, that was a subset, when A has the elements 1, 2, and 3, and B has the elements 3, 2, and 1, these two are equal. A is a subset of B, but A and B are exactly the same. So A is not a proper subset of B. Okay. So here, A is a subset of B, but it's not a proper subset. So proper always takes a little bit more effort for it to happen. All right. So we are almost done with this section. I have one more kind of interesting example to go over. And what I want to ask is the empty set a subset of this set, 1 through 50? So this one's really hard to kind of think of. If I want something to be a subset, all the elements here have to be elements here. But the empty set contains nothing. So what does that mean? Okay. So in this case, we're going to actually think of this in the opposite way. Go back up here. This is not a subset of B because I found an element in A that was not in set B. So if they're not subsets, I should be able to find something in the smaller one that's not in the bigger one. But I can't do that with the empty set because there's nothing. So here, if the empty set is not a subset of 1, 2, 3, all the way up to 50, we need to find an element in the empty set, which again, remember, is just the set that contains nothing. We need to find an element in the empty set which is not in the set 1, 2, 3 through 50. Okay. If I can do this, it's not a subset. But because this has no elements, there's no way I can figure that out, or no way I can actually accomplish that. So since the empty set contains no elements, this can't be done. So I can't contradict my subset definition. I cannot find an element in the empty set which is not in the set 1 through 50. So ultimately, it is the subset. So the empty set is indeed a subset of 1 through 50. Okay. And so that's really, really strange to think of, that this is a subset. But really, it didn't matter what I put here. No matter the elements, there is no physical way I can find something in the empty set that is not in whatever set I put over here. So in fact, the empty set is a subset of every set. every single set. If I start with the empty set and my subset notation, it is a subset of everything. Okay. So the last thing I have for this section is really kind of finding all subsets of a set. Okay. Let's see, can I squeeze it in here? Maybe. We'll see. Okay. So now, what if we're given a set? And we need to find every subset. Okay. How many ways can we do that? And what are the subsets? Okay. So I'm going to actually build a chart where we're going to look at the set itself. We're going to list all of the subsets, and we're going to figure out what that number of subsets is. And we'll see if we can find some type of generalization for this. So let's start with the empty set. There are no elements to this thing. The only subset that is a subset, or the only set that is a subset of the empty set is the empty set itself. Okay. So there is one subset here. So that one's a little annoying, I know. Now if I have a one element set, I'm just going to use like A, B, C. There's one element here. My possible subsets are the empty set and then the set itself. Because remember, if they're equal, they're subsets of each other. So counting those, I have two subsets for a one element set. Okay. If I bump this up and put two elements in here, well, then my possible subsets are still the empty set. If I make a set that has just A, that is a subset of AB. And if I make a set containing B, that is a subset as well. And then the set itself is also a subset. So ultimately, we have 1, 2, 3, 4 subsets when there are two elements. We'll do one more, and then we should be able to see a pattern. Let's do 3 elements. Okay. Still got the empty set. Then we've got the set A, B, and C separately. So every element in here is an element here. Every element here is an element here. Every element here is an element here. So that's my one element subsets. Then I compare 2 of these. If we put A and B together, both of those are in ABC. If we put A and C together, or B and C together, so I pair up 2 of them. All of these are elements in here. Okay. And then finally, we have the set itself. Okay. So in total, we have 1, 2, 3, 4, 5, 6, 7, 8 subsets for 3 elements. Okay. So kind of really looking back, what happens is it doubles every single time. If I have 4 elements, there's going to be 16 subsets. Okay. So the way you can actually see this is 8 is 2 to the 3rd power. 4 is 2 to the 2nd. 2 is 2 to the 1st. And 1 is 2 to the 0. Okay. So ultimately, the number of distinct subsets of a finite set A is 2 to the n, where n is the number of elements in set A. So i.e. n is the cardinality of A. Okay. Now, if I want to go back and talk about proper instead, basically I'd get rid of this set, this set, this set, and this set. Each time a proper subset would not be the set itself. So underneath here, the number of proper is going to be 0. Number of proper is I have to get rid of this one. So there is one proper subset. Here, I would get rid of the set AB. I have 3 that are proper. And in this last set, the number of proper is 7. So basically every single time I'm going to subtract just one set, which is the set itself. Okay. So the number of distinct proper subsets is going to be 2 to the n minus 1. Okay. So let's do one example. If the cardinality of set A is 5, we're going to find the number of subsets and the number of proper subsets for set A. Okay. So let's start with just subsets. It's going to be 2 to the 5th, which is 32. The number of proper is going to be 2 to the 5th minus 1. So 32 minus 1, there would be 31 proper subsets. Okay. I'll do one more example. If set A contains the elements, what do I want to do? Let's do Mickey, Minnie, and Pluto. 3 elements. We're going to find the number of subsets and list of the subsets. Okay. And so this set has 3 elements. So the number of subsets is going to be 2 to the 3rd. There are 8. And now we want to actually list them. So remember, I kind of like to go by number of elements. So 0 element subsets, 1 element subsets, 2 element, followed by 3 element. My 0 element subsets are just the empty set. My 1 element would be each one on their own. So Mickey, Minnie, and Pluto. My 2 element pairs 2 together. So Mickey and Minnie, Mickey and Pluto, and then Minnie and Pluto. So that pairs each one together. And then finally my 3 elements, Mickey, Minnie, and Pluto. So just the set itself. So in total, that gives me 1, 2, 3, 4, 5, 6, 7, all 8 of them. So this is just a nice way to kind of keep track of all of the subsets by putting them in that increasing order.